I want to talk about chain of responsibility, and the way I want to do that is not by showing you a theoretical example, but by looking at a real application and how we could use chain of responsibility to simplify it. I have this application I call the Teamsifier, and what it lets me do is I can take a link to Teams, the Microsoft communication tool, and I can extract from that link a link to a SharePoint document. Why would I do that? My computer can open more than one window at a time, and Teams has made this decision where everything opens in one window. So if I'm looking at a conversation in Teams and I click on a link, the thing that I'm opening replaces the view that I'm looking at. And often I don't want it to. So the Teamsifier lets me strip the hidden link out of that Teams link, so I can open both things at once. It's a good application to use to do that because it started out with a really clean design and it got a bit messy. So the very first version did what I've just shown. You paste in a link, you get the de-Teamsified link, but also sometimes you want to say, well, that's not even a URL that you've put in the box, or you might want to say that it is a Teams link, but not one that this application can do anything with. So here we have an example. There you go. That Teams link doesn't contain a hidden link. And then very recently I discovered there's a whole other kind of hidden link which you couldn't de-Teamsify in the same way. So this started with a nice clean pipes and filters approach. Using RxJS, get all of the input events from a particular element in the page, pipe them through a debounce, which if you've not seen before means here only give me an event every 200 milliseconds regardless of how fast they're coming through, which gives someone the time to type into the box. When you've got that event, turn it into the value inside of the box, filter it out if it doesn't have content, filter it out if it isn't valid HTTP URL, turn it into a URL, check if it's a Teams link, check that it might contain a secret hidden link, and de-Teamsify. Two of the messinesses that have crept in there, I added this send mechanism, so the blue box here, you get text into that by using send, and that's an RxJS subject. So what that lets me do is set up this behavior. Whenever someone sends me a message, you pump it into the next of the subject, and whenever that receives a message, it puts that text into the page. I can't remember what I was thinking at the time, because that adds a side effect to this method that isn't obvious from the implementation. So it has content here, looks like something that takes a string and returns a boolean, but it has this side effect of changing the DOM as well. That's quite yucky. And then this de-Teamsify method used to do one thing, and now it does two. So it checks for an object URL, the first kind of hidden URL. It checks for a viewer URL, and then you either, with this message side effect, you either return the hidden URL, the viewer URL, or you say this is some unexpected state the application shouldn't be in. So while it was a linear pipe, it's now a pipe with a branch in it. And chain of responsibility is a great pattern for dealing with this. So we can run passing tests, and we can run failing tests. And because we're using Typescript and Mocha, I couldn't figure out how to get watch working, and I just gave up. One of the reasons to use Typescript is that we can lean on the type system, so we can say what is chain of responsibility when I look at the types. I can give myself an interface called chain link. So chain is made out of links. Each of the links in the chain is going to handle some input. Right now I can't think of a better name than handle, and it's coming from the DOM, so we're going to say it's a string, and it will give me a result. And for now I'm going to say that result is an empty interface. That's not how that works. So the chain link interface has a single method called handle, which takes a string and returns a chain result. Chain result is empty. Chain of responsibility says it's a chain of items, each of which receive the input, and they decide if each link decides if it's responsible for dealing with this input. So here we'd have a has content link in the chain, and it says, am I responsible for dealing with this? And if it is, it returns the result, and that's the end of the processing. And if it's not, it passes on to the next link in the chain. So let's start with that. Has content, which checks if this is a string with some length. So how are we going to test this? We're going to have a result, and we want to know that the empty string returns an error message. So I would expect the error to equal there must be content in the string, and I would expect to get the error, get the result, by saying I have a new has content, and that's going to handle the empty string. We can create that, and we can say it implements chain link, which will mean we can fill this in, and we should have enough there to get a failing test, because we're returning undefined, and undefined doesn't have an error, and so we can return instead an error, and that should fail because there's no content in that string. Brilliant. I'm going to be lazy, I'm not going to type that out again. Brill. Property error doesn't exist on chain result, and I'm going to take a slightly bigger step, and I'm going to say it's optional. Not every result is always going to have an error. So this we can detect that the empty string is invalid, and then we want to test the other side of that. We can pass on to the second link in a chain when there is content in the input. So this time we're not going to have an error because there is content and we're passing on to something else. I'm going to put that into hidden URL. And we're going to expect that to equal tick. Why hidden URL? Hidden URL because that's one of the properties we know we're going to head towards. And why a tick? Because I need a fake way to terminate this chain. And so I'm going to have an always succeeds chain link, which I can't spell. And that's going to handle literally any content. Why are we doing this? I'm doing this because I actually expect to delete a bunch of these tests when we're finished. I would have liked to write this outside in, so start with just the behaviour of the application, given some input, something occurs, and not what we're doing here inside out. Given a tiny piece of the puzzle, the tiny piece of the puzzle works, and then I can keep building on top of that. I didn't want to have lots of mocks and fakes, which often goes with an outside-in approach. So let's start inside out. By the time we've got some tests that actually exercise a real chain, because there are no dependencies on the outside world in order to run this code, we can then probably delete a bunch of tests, leave ourselves with the finished outside contract that doesn't depend on the implementation, it doesn't care that there's a chain of responsibility in there. In order to get to that point, I need a fake way of ending the chain, and the always succeeds is going to do that. So this always succeeds is going to implement chain link, and we're going to implement all the members, and this always returns a hidden URL with the value tick. Now it's unhappy because chain link doesn't have chain result doesn't have hidden URL on it, so hidden URL can be another optional property on the response. So now has content doesn't expect to receive another link in the chain, and the IDE won't help me, so we can add a constructor. That constructor takes the next link in the chain, which is always going to be a chain link, and surely we don't have to type that, brilliant. And we can store that next link ready for use. So this can have that as well. So we should just have one failing test, and it should be because there's no tick. There is no tick, and we can come back here and say inside of has content if s and s dot length is greater than 0. So if there is content in the string, we're going to return next link handle s. So we're going to say, yep, someone else in the chain is going to handle this. Otherwise, we can return our error, and that should pass, and it does. So far so good. Let's have going to have a chain that detects valid HTTP URLs. So I'm going to write quite a big test to more quickly get to the point about chain of responsibility rather than necessarily doing very good TDD. So here we're going to have a bunch of expectations. So when the chain handles some text, I'm going to expect that to have the property error. So our change gives an error when the text is clearly not a URL. When we have something that is a URL but isn't HTTP URL, then we'll also have an error. And when there's a HTTP URL, we're going to have hidden URL. Now, if we were slowly pushing this out with tests, we should be testing the values of these errors and that there is and isn't. You know, when there is an error, there isn't a hidden URL and so on, but hopefully it's still clear if I skip over that. What's our chain? It starts with a has content, then it's going to have a is HTTP URL, and then it's going to have an always succeeds. If we run that, it will tell us that is HTTP URL isn't defined, which we know because it's red on the screen. We can create that, and it takes a next link, which is a chain link, and it stores that in a field, and it's going to have a handle method, and that's going to have some stuff in it. Let's find the current implementation. We know that works in the existing method, and we're taking a big step, so we'll bring that in and we'll see what we've got. So the first thing we do is try and convert the string to URL. If that doesn't work, then we're going to return our error. Return the error. The teams, so you must provide an HTTP, provide a web URL. Let's assume it's for a user and there's some good content here. If it is a URL, then we get past this point. If it's got HTTP or HTTPS as a protocol, then this link in the chain doesn't handle it. We're going to pass it on to the next link in the chain. Otherwise, we've got that same error again. So there's a bit of duplication in there, but let's not worry about that right now. We now have code that we can run, and it passes. It should also be possible for it to fail. Brilliant, and we can see in there that if we were being more thorough, we would get the output that we expect. So if we look at what the next link in the chain is, that at this point we convert that to a URL and we filter that URL for whether or not it's a Teams link. And what does that look like? Well, that says if the host of the URL is teams.microsoft.com, then this is a Teams link, otherwise it's not. And so we have a decision to make now. Let's be very lazy and copy the whole test it can have, a chain that detects Teams URLs. And so that means we're going to have, if it's example.io, then we're going to expect an error. And if it's teams.microsoft.com, then we're going to expect hidden URL. So that means this chain is wrong. We have another is Teams URL, and that takes this. As an aside, this arrow of constructors might be making you unhappy. That is a messy way to construct things. I'm purposefully writing tests that have the whole chain, and purposefully leaving this as a big block that you have to read, to keep reminding me that that could be refactored. This could be a much nicer way of creating a chain than what we have there. But right now what I want to do is start creating this so we see the problem that we've got. Implement all members. So and store that as a field. So the test should fail for the reason we expect. Target can't be null or defined. Null or defined, which I believe is because of this. So I could convert this input into URL inside of his Teams URL. But that means anything after this in the chain, we have to keep converting the string to a URL. It hides the URL implementation from the outside world. You could change the signature of this method so it could take a string or a URL. But now every link in the chain has to receive either a string or a URL, and then inside of it check whether or not it has a string or a URL, and have behavior based on whether it's a string or whether it's a URL, whether that's what it's expecting or not, which is going to generate, a few lines of code in every link in the chain. Or we could make this interface generic. I'm leaning in that direction right now. So let's get the test passing and then make that change. So we're going to have something that we're going to throw away in a second, which will be that. Why are we unhappy? Oh, right, because we're still writing the code. We can steal the implementation and say we're coming back here. So if the host is Teams, then we're going to pass on to the next link in the chain. Otherwise, we're going to return an error, and let's have that say that's not a Teams link. I think the test passes. Yeah. And I'm about to mess about quite a bit, so let's just get a commit in there so we can unwind this if I get confused. So my family interrupted me and I've restarted recording on another day, this time without rain, so it won't be quite as ASMR as it was last time. It's tempting to recap because it's been several days for me, but it has been literally an instant for you. So the next thing in the chain, we've checked has content, we've checked is HTTP URL, we've checked is Teams URL. We can look at our original pipe. We've checked it has content, that it's a valid URL, and that it's a Teams link. But you can see we've missed this step here where we map to a URL. Inside our implementation here, we're mapping to a URL and passing a string on down the chain. We could stay like this. There's a good chance that subsequent steps have to care that it's a URL. Let's look at that. So we've checked it's a Teams link, might contain a hidden link. So in that we do have a URL, not a string, and we treat it as a host. And then we deteamsify, and in here that's a URL, and we take its hash. In here it's a URL, and we care that it has search params. So each of the filters after the point we're looking at know that it's a URL, care that it's a URL, and we're passing them a string. We could convert to a URL at every step, but that's, in my opinion, that's hiding some information. We know this is a URL, and we should make that clear to the outside world. It's not appropriate to call this method on this chain with a string. It's a URL, and we should enforce that. Or it's not appropriate to pass on to the next method from this link in the chain a string when we know that it's a URL, and we want the subsequent links in the chain to care that it's a URL as well. If we look at is HTTP URL, the only way you can get a successful run through this method is to have converted it to a URL. Passing on a string weakens the chain, it makes the chain less obvious. How could we fix this? So we have this method handle which takes a string. Typescript is lovely, it will let me do that. And so there I'm saying that this method takes either a string or a URL, but that means for every instance of a chain link I have to care. Now the handle of has content takes string or URL. I now can't call length without handling it. So while I've tried to make the chain links after the is HTTP URL more clear, I've made the chain links before that less clear. They have to care about something that actually they don't need to care about. Let's get rid of that. What we can do is make this generic. So we can say that this is a chain link of type let's say it's a type T receive. It's common to do this. T, it's a type T. You can do that as well. I'm not completely happy with T receive, but I think it's a little clearer. This is a chain link that receives a particular type. So now we have to fix up this one. This is a chain link of type string, and it passes on to a chain link of type string. So we're really starting to get information about why is that unhappy? Types of parameter S and S are incompatible because I'm a silly man. It's a type string. Always succeed. Well, actually, it doesn't care what it receives. Is HTTP URL. We've said that's a type string, but that it passes on to a chain link that receives URL. So we've got a little bit of information now about how the chain is supposed to be constructed, and we can call that URL. Now, is Teams URL is now a chain link which receives a URL and which passes on to the URL. It takes a URL, which means it doesn't need that. Okay, now new always succeeds. It's not assignable to parameter of type chain link URL. Okay, well, always succeeds. We're going to delete. It's not going to live past us being able to construct a real chain. So whilst it actually doesn't care what it takes, I'm quite happy to pretend that it cares about URL. And then it can't go in there. Fun. Can we say that it's string or URL? And that this is string or URL? Yes, we can. Brilliant. I really do love some of how the Typescript type system is set up. Tests should still pass, and they do. We could have a brief but necessary divergence into single letter variable names, but we don't have to at the moment. We can say, however, that S of T receive doesn't make any sense, where S of string did. I'm going to change it to X and say right now that doesn't have a name, effectively. I don't care what the name of that thing is, it's the thing I receive. And then we're going to think about what the next test is. Once we've checked that something has a Teams URL, then we say it might contain a secret hidden link. So in this implementation, this existing implementation, we check if it has a link in the search params or it has a viewer URL in the hash, then we're good. We're going to pass on to the next link in the chain. Otherwise, we've got a couple of error cases. One, the URL path name includes channel or thread.skype, in which case it's a link to a Teams channel. Otherwise, it's a Teams link, but not one that we care about. Generic error condition. So this is the point where we have a split in the chain. So this is a chain link that makes a decision for us. Are we going to process the remainder of this chain as if it's got a link in the search param or a viewer URL in the hash? Which means we need to write an even bigger test if we're going to carry on with using the tests just to guide the implementation and make sure I don't make a mistake, rather than to drive the design. So it can have a chain that decides between two routes, paths. Decides between, and there's my dog. Who has seen a blackbird? So we can have a chain that decides between two paths. It's fine for now. So where we have new is Teams URL, we can then have a new type of Teams URL. Now that will take two subsequent links in the chain, and unfortunately for us, at the minute we only have one way of detecting success. So this is where not using a mocking framework makes this a bit wordy. But remember, this is all getting deleted. Most of these tests can be deleted once we have the structure, and we can make it look as if we designed this outside in. So we're going to have an always succeeds, and that's actually always succeeds with a tick. Let me check that's true. Yeah, it is a few days since I recorded the first half. And we're also going to have always succeeds with a smile. So it's just a little bit of scaffolding to get us over the hump of not having our true terminal points of the chain, links in the chain. So I've now got two things I'll have to create, and I've got very long links that I could put into here, and I don't want long links. It's not an integration test against a real link. I want it to be a test which helps us understand what's happening. So if we come back over here and back into this, if u.search includes this, then it has a link in the search param as far as our logic is concerned. So we can say query parameter anything equals that. Now that's not what we'll actually receive from Teams, but that will make the test pass. And we expect that to have own property hidden URL. We also have this condition in the hash. We expect that to have hidden URL. And I want some error cases as well. So something, and that should have error. And the hash can have something, and that should have error. And we had this case as well. URL path name includes channel or thread.skype, and we should get a different error message. So let's grab that condition. So URL path name thread.skype, and we should have an error, and also channel. We should have an error. Now really we should call out these strings, but again I'm just making sure I haven't made a mistake. I'm not using the tests properly. So I think that will fail, but I don't know. That's an awful lot of code. Oh no, it definitely will fail. Type of Teams URL doesn't exist. Yeah. So we can create that. And what are its names here? Well, the test isn't forcing this, but we happen to know that one of these is a link in search param, link in search param next. that's a chain link of type URL. And it's a viewer URL in hash next, and it's a chain link, whoops, of type URL. We can store those, and this needs to be a chain link of type URL. So it receives a URL, passes on to one of two. We can implement that method. And now we should get a different error. Always succeeds with a smile isn't defined. Let's do very bad people and duplicate that. So if you're not used to code that looks like this, I don't have a smile in my frequently used. That's a poor representation of my state of mind. If you're not used to code that looks like this, that doing this to avoid mocking frameworks, imagine that I had two mocks, and in my tests I'm going to assert that mock A was interacted with, mock A was interacted with, and mock B was not interacted with. That's effectively what we're going to be testing. So we're going to come down here. I've just said something that the tests don't. The tests don't enforce. Here we're going to have a hidden URL of a tick. Here we're going to have a hidden URL of a smile. So now we should get an actual failure. Target can't be null or undefined. Brilliant. Because we're getting that because we have an undefined in here. We're going to be super lazy. We're going to capture these two things and pop them in here. And we're going to steal this and pop it there. Why is that unhappy? Duplicated code fragment. Okay, we'll find out where that's duplicated. So we have a URL. If now we have to change this straight away. Will the IDE do that? Great. So if it has a link in search param, then we're going to have link in search param next, handle URL. Otherwise, this dot view URL in hash handle URL. As we've done elsewhere, we're going to convert this send into an error. And now I think that's enough code to make that pass. Yeah, brilliant. That's no longer showing as duplicated. I could have a bit of white space. You can see the difference between the IDE and my tastes. I haven't set up a linter to enforce correctness. So I prefer a lack of semicolons, but I haven't set up a linter to enforce that as I go. That's a really big test. So now we can say it has content. If it's a HTTP URL that's a Teams URL, we can choose to go down one of two routes. And now we are back to this dteamsify, which hid a lot. It hid our different routes. So what we have in here, if the item if the input is a Teams link with search params that contain a Teams link, then this is how we get it out. So the next thing we're going to do is we're going to have a chain which can read the hidden link from search params. So it's going to look a lot like this implementation here. However, this branch here is going to be read Teams link from search params. If I could type, at least it would be. We're covered in earlier tests there. I'm only going to check these two cases in this test. We're going to go to the README, and we're going to take here. Let's take a slightly longer example and put that into there, and we're going to expect the hidden URL to be oops, didn't grab enough to F. We don't need to run it to find out that doesn't exist. The IDE is telling us that, and it implements chain link of URL. It doesn't need a constructor. This is a terminating link in the chain, and it's receiving a URL, and it has some implementation. Oops. URL dot search params. It's going to return hidden URL. It's not happy about that because it returns a chain result, and string or null is not assignable to type string or undefined. Search params.get, presumably well, let me just check if that passes the tests. No, because we got null. This is where taking big steps isn't helping. And so I'm going to have to do this because actually I don't understand why that hasn't worked. And if we get really stuck, we can write a smaller test to force us to understand what's happening. So search params is empty, and that's not what we expected because we're giving it search params here. let's try that again. So it's there, and search. So what's the difference between search and search params? JS URL search versus search params. MDN, Mozilla Developer Network, if you've not used it, is incredible. It returns a URL search params object allowing access to the decoded query arguments contained in the URL. So if we have a URL, name equals Jonathan Smith and age equals 18, URL search params gives you those, and I wonder if it's very mean and you have to have a slash on the end of the so we've still got hidden URL of null. We've still got a search that shows us having anything. We've still got a URL that's picking it out. Wait, hang on, look. Object URL. Just check I'm not being completely foolish. Object URL. Yeah, okay, I was being slightly foolish. So if that was too quick for people, once you've got search params, read the object URL out of it, but I was passing search params that only contained anything. I could have fixed it by putting anything in here, but we knew the test was incorrect. Let's see if it really needed that slash. It didn't, so I like that. The problem was me and not the computer. So we have another error case here that isn't covered, and that's where we have an object URL, but nothing in it. So I think we can get there with that, even though this link shouldn't receive that input. The themes object URL parameter must have content. Let's see. So yeah, we were caught earlier in the chain. Now we're a bit stuck. If this is called correctly, then hidden URL is not null. In fact, it's a string. Can I say, look, it really is a string? And then it complains because we might assign null to it. So we could say unknown. I can lose that. That's a bit yucky. We should possibly come back and make that better. This would, there's a chance someone misconfigures the application, including me. There's a chance I do it, and a user sees the word unknown. Let's make this unexpected error. Let's make it unexpected error at least. So the type system is telling me, well, it is possible to not behave the way you think in this method. So even though I don't intend to make that mistake. It is possible. We've at least got something there. It isn't covered by test. We would have to write a test for this chain link by itself. In the real flow of work, I would write that down on a piece of paper on my desk. On your team, you might say to do, write a test on this error case for this link in isolation to remind yourself to come back to it. I tend to avoid this because my experience is I find to-dos in a code base and they're 18 months old. Well, what do you do in that case? You just delete the to-do. If you've coped for 18 months, then you don't need it. I write my to-do list on my desk in some way and come back before I've finished. So we can now exercise one side of this. We can read a Teams link from search params. Let's select this method and duplicate it. It can have a chain which can read the hidden link from the URL hash. We're going to read the viewer URL, and then in here read viewer URL from hash. I've got actual tests for that, so let me just double check how that looks. Let's steal this example. So that makes this example, and it's going to be on the clops.sharepoint.com/sites. Okay. And it's not going to come to us there, it's going to come to us viewer URL. And in the case I've replaced the wrong one, let's just unwind that. So in the case it's a viewer URL, then we're going to have a viewer URL with something a lot like this value, but it's on the clops, not example. In the case that it's so not an object URL, and that's going to give us some error. We can create that class. It implements a chain link which receives the URL, which means we have to implement the method. We don't want that called X because we know it's a URL, and then we need some return of viewer URL. We should get some help here that viewer URL doesn't exist on chain result. Viewer URL, which may. So this interface is a bit yucky, but I don't mind it really. Our chain result has one of these things. If we really needed to, well, we could turn this into a class. We could give an implementation that makes it easy to read this, or gives us a type hint of what we've received. So if we come back down to our test, we should get an error in the case where it's not one of the options that we expect, or we should get a URL in the case where it's a view URL, but we won't because we haven't written that code. So we expected view URL to have particular content, but it didn't. It was an empty string. Well, we hard coded it. If we come back here, then I've gone into the wrong place, deteamsifier. So from hash, deteamsing result. Look at that. So for start, it's download URL, not view URL. So we have an implementation here. Comes into our tests. Comes up here. Find the implementation. Let's call that U for now. So if the hash starts with, oh, and there's a thing, it only works for Excel spreadsheets, then return undefined. We don't want that. Otherwise, do a bit of text munging and return that download URL. So let's return the download URL there for now. And we're going to return an error. This viewer URL isn't can't be processed. Please report a bug. Let's try that again. Brilliant. We know to rename this. Download URL. Oh, excuse me. Must be the COVID. Burn me. So we're now at the point where we don't need these fakes or stubs or whatever they are, because we can construct a real chain. This is the actual chain that would be used in production when we get around to switching over to it. So we could look at a few things now. There's a limited number of routes through this, and we can start to be a bit more concrete. Can detect that the empty string is invalid. Well, first, let's do this. Let's, I want to create this every time, and I want it inside. Yeah, okay. Create chain. I didn't expect it to have. Where's that gone? It's here. Let's put this up at the top. And we're going to do this in before each. Before each. We're going to make ourselves a new chain. The chain is stateless, isn't it? It doesn't care how many times it's been called. No. I'm getting overexcited. We just create the chain once and we reuse it. That's fine. So in here, we're going to say create chain. I don't need to keep typing that. In here, we're going to say create chain. It's going to break a bunch of tests. We're going to create the chain. We're going to create a chain. So what I'm doing now, again, this isn't TDD. I am just seeking. Oh, did I do it in the wrong method? Yeah, phew. That would have been a confusing error. It's not TDD. I'm just trying to seek which tests I can delete, which I fix, and which I separate. So I'm expecting a bunch of stuff to stop working there. Yeah. So, okay, I think I might have started refactoring before I made the test screen. The URL, I had to send the TDD police to my house because I didn't mean to do that. So, what have we got here? We expected object error to have own property hidden URL. So whereas before we were being handled by a fake implementation of this, we're now not. So we're going to find out what error we're receiving. There we go. So there's our text that we added. It's been picked up by an existing thing. Let's see what's next. So this will be, can have a chain that decides between two paths. Have a chain. So again, we're here. We're not hitting our fake anymore. So, but got unexpected error. Maybe refresh and try again. So we're gonna just double check I'm on the right line. Yeah, I'm gonna make this. Maybe refresh and try again. Oh, the computer's fighting me. Now, we should probably expect that for the next line as well. What's that? 186. Oh. Yeah, that's not right. Let's find unexpected error in this file. Yeah, not at all what I meant. So we're gonna, if we're gonna return hidden URL, then hidden URL, otherwise that error. So now we're on 186. We've got an error, PMT, and it's going to be this view URL can't be processed. Using chain of responsibility to Teamsify can have a chain that detects Teams URLs, line 169. So we've created a chain, we've passed in Teams, Microsoft.com, we're getting an error instead of a hidden URL because we're no longer using that mock at the end of the chain. And so we now maybe care about the actual error text. So the interesting thing about this, we can create a chain that detects Teams URLs. We're implicitly testing that. You can see here, I'm sending the Teams URL, I'm getting an error from, I happen to know I'm getting an error from further down the chain. And what we said at the beginning was, I want to not test the implementation here. I don't care that it's chain of responsibility. I'm going to delete this test. I'm happy that that's being covered elsewhere. So line 162, have a chain that detects valid HTTPS URLs. So if we get example.io, we get error, that's not a Teams link. So again, I'm now implicitly testing. No, what's going on there? We're now implicitly testing something inside the chain. So we expected error. That's not a Teams link. To have own property, that's not a Teams link. Oh, yeah. Because I can't. Because it's hard to talk and type as I'm demonstrating. So I deleted the test. Actually, that's not the only thing I could have done. Let's put the deleted test back for a second, because we're not on green. 162, that's the next test that we fixed. We can pass on to the second link in the chain. Now we've got an entire chain where we pass literally any content. We're not going to have hidden URL. We're going to expect result to have own property error. You must provide a web URL. Okay. 12 passing. Brilliant. So we can commit where we are. Can test the entire chain of responsibility. Implementation of the teamsifying. So unexpected error may be refreshed. So we actually picked up that test for free, quote unquote. Now we can look at what we have here. What we have is a set of tests which don't quite all look the same. We expect result to have own property error. So what we have is a set of tests. Each one creates a chain, handles some input, and tests one or more properties coming out the end of it. So we can switch to this. We can put user input, and that's going to be the empty string. That's going to have expected property, which is going to be error, and it's going to have expected value, which is going to be there must be content in the string. Now, why is that unhappy? It cannot be used as an index type. Okay, for each test case, yep, I don't know why that's unhappy, but it'll work like that. Okay, so we have a single test case right now. For each of those test cases, we can say, let's give ourselves a template string on receiving user input chain outputs and test case dot expected property. Okay, inside of this test, we're going to create a chain. We're going to handle test case dot user input, and we're going to expect that have own property. Blimey, that's a bit of a mess, but we're going to expect test case dot expected property has test case, whoops, daisy test case dot expected value. So for anything in this array, get a chain to handle it, and then assert on what's coming to it. So we had 12 passing tests, we should now have 13. Yeah, we do. And one of them will be on receiving user input blank, chain outputs an error blank. Why is that blank? Well, that's blank because the user input is actually blank. And then that wasn't blank, it's error is what we're expecting. And here, whoops, user input. Let's try that again, npmt. On receiving user input, the empty string, chain outputs an error. So that is this test. And if we change that, it will fail. Yep. Why? Because it wanted that value and it got this one. So we can undo that. And that removes this test. And then we say if we handle literally any content, we'll get you must provide a web URL. So we can add another test case of literally any content and get you must provide a web URL. Now we'll see that. We'll get one failing test, and we've not passed. You must provide a web URL. That replaces this test. Now we have 3 inputs. Some text is duplicated. That's literally any text. And then the next one is an FTP URL. So let's put a trailing what's it there and duplicate that. The user input of blah gives me an error. What error am I expecting? You must provide a web URL, wicked. Next one, https example.io. Don't have to copy that. This one should fail because the error message changes. Yep, that's not a Teams link. Back to green. And that covers this test. Example.io, that's duplicated. Teams.microsoft.com, and then we'll get that string. So let's duplicate this test case. Teams, whoa, there, teams.microsoft.com. We'll now get a different error message. Starting, that's not a Teams link. And that deletes this test body. Now we can have a chain which decides between 2 paths. So we're now getting to the point where I think actually maybe each of these strings is important to us. Let's see. This one. And this one. this one. I'm going to lose track of this when I come back to it, because I'm doing lots of tests at once, which we shouldn't. But again, I'm not test driving this. I've missed the opportunity of doing that previously when I've built the application up. And what we're doing is we're using these tests to make sure I don't make a silly mistake while I'm doing this, so I don't have much discipline around how I'm using the tests. Alright, so that's a bunch of tests in one go. So on receiving the user input, where we've just got the hash 2f2f, we get that this viewer URL can't be processed. Well, I remember us implementing that. On receiving the input, anything has that encoded start of a URL, then we got unexpected error. So that's this one. What are we down to? On receiving the user input with /channel, we get that error message. No, hang on. Expected an actual is in red. Okay, 209, so that should change. Oh no, well, every one is the same. Thread.skype. Okay, so that's the same error condition. Passing. Wicked. I don't need that little marker anymore. And I can delete this. It can have a change, and now we're on to excuse me, we're on to something that has success conditions. So I want this string as my input. It's not going to give me an error, it's going to give me a hidden URL, and that hidden URL is this. No, it's not. I was a bit too quick with my growing my selection. Yep. Now we've got, I'm going to assert we've got that error case covered above, and it's this one. And the change here is on the clocks. And it's not hidden URL, it's download URL. Brilliant. And that deletes that test. So we have a set of test cases which I think is probably complete. It may not be. If you were working with me and we thought of one, we'd just add it. If the code didn't handle that sensibly, then we're back into a test-driven loop now where new behavior is being added to the application. I'm quite used to this approach to writing tests. I love it. It reads clearly to me. It might break your brain, in which case that's fine. Leave it as however many tests this works out as. 19 individual tests. It feels like repetition to me. Once we get to this point where we know actually this is really concrete behavior, it's a really concrete code, and we don't care if somebody completely changes the implementation inside of create chain, inside of handle, because we've covered every case of the behavior. If someone doesn't like chain of responsibility, thinks I shouldn't have made this change, they can come along in the future and change it. I might come back in 6 months and decide I don't like this, I'm going to change it. Right now though, it's a good point to commit. Parameterized tests. Oh, don't need to push. Right now though, all our implementation code is still in the test class. Let's chain of responsibility.ts. Let's leave it in one file for now. And what are we taking? We're taking the chain result, the chain link, we're taking each of that, we'll delete those in a second, we're taking each of the links, and actually we should take create chain as well. So let's take that and move them here. How clever is all of that? Good, it's finding it even though it's not exported. That confuses me. I don't think that's right. I think that's the IDE being too clever. Whoops, that's not what I meant to do. I'm going to export each interface. We're going to export each class. We're going to come into here and we're going to add an import statement. I want to do it for add all unambiguous imports. Right. Test should still pass. They do. I must have deleted a test since I had 19 and now I have 18. I must have counted 19 before I deleted the final test. And we're going to move the implementation of create chain into here. And come back here and boom, 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 we can import it. We now don't need any of those imports because the chain is opaque to the code. If somebody decides they can implement it a completely different way, they're welcome to. It won't break the tests. They might choose to test drive those changes, but they don't, it doesn't change these tests that we have currently. We can delete those unused ones. Now, we could refactor to a nicer way of creating the chain, but it's only in one place and it's only constructed in one way, so actually I'm happy to leave it. We could go through and give you a better name in each place. You're welcome to. Actually, it's inconsistent, so the real reason to change it there is that it's inconsistent. So URL is going to be URL the whole way through. We could have changed it to U the whole way through. It's almost doesn't matter. It's almost entirely preference. We should go through and make our white space neat the whole way through. Whoops. And then we're going to commit all implementation of chain of responsibility pattern is now in source, not test folder. So we could go through and refactor things at this point. some of those things are preference, some of them aren't. Some stuff is just, it's better one way than the other. But right now, the thing I really want to fix, even though I've gone through and I should have just amended the commit, but I've gone through and made changes since the commit. What we have right now is we have the opportunity to actually use this and then see if it works. So we are going to think about how this would work. So we're still going to debounce, then we're going to map to the result of the chain. So we can, we can have a const d teams if I chain equals create chain. That should have added an import for me. It did. Brilliant. And then we're going to map. We're going to map to the value of the input box, and then we're going to map to create chain. Oops. D teams if I chain handle x. There's a chance we can get rid of all of that. It's unhappy. Why is it unhappy? Argument of type boolean is not assignable to parameter of type value string. Insert a let declaration for x. This is a string. Map to the string. Okay, I thought that was a very odd looking error. So now has content isn't used. On next is still used. On end is still used. Just dropped my desk whiteboard. So what happens on next? If we don't have a result, what's a dteams in result? It has hidden URL or download URL. Right, we don't have that anymore. In fact, we don't have a dteamsifier at all anymore. This is a big change. Hang on. That's no longer a dteams in result, it's a chain result. That's a bit neater. So we now get a chain result in this on next. I could have implemented this a bit safer, but okay. Now, if S has a hidden URL, we're going to do one thing. If S has a download URL, we're going to do another. And then by extension, it's got error. And so we can lean on send for now, and we can send s.error. String or undefined. Let's have another catch-all. Unexpected error. Please log bug. This area already isn't under test. Really, we should bring it under test, but so we could have added a second implementation alongside here, and well, actually, what would that look like? Let's assume this was scary and dangerous to change in production, and it is. It doesn't have any tests. Let's git reset. So we've now got one pipe, and we add our new pipe. We need a dteamsify chain in here. Const dteamsify chain equals create chain, and we're going to console.log and console.log. So our application, other than this, which adds new behavior, the actual application hasn't changed at this point. We've not removed any code, we've not deleted anything, everything should work the same way. The README should tell me how to build it locally. It doesn't. Haha. Not that one. This one. Okay, we can just build it. npm run build. So the build should run. Oh, good. What have we got here? Okay. Good, it was just Node version strangeness. So that's changed the website. We can open the website, we can come in here and do a test, and we should, in the console, have you must provide a web URL. So we could keep going through. If we go back to our application here, in the README, we've got this string. We can put that string in the box. That shows a deteamsified link in here, and it shows the hidden URL there. So we can gain confidence in production, possibly with a different logging method than just console.log, but we can gain confidence before we implement this change, which is a big change all in one go, that it's going to work. If you wanted to now, you could flip this. So we can come here, we can say on next is going to be in here, on error is going to be in here, and our original mechanism is going to become console.log. Now still might need to make changes, maybe that let's if we open that, paste that link in, you know, now I've got my original thing is here, so I can flip a feature flag or make a release. I'm using the new mechanism, but I have the old mechanism there for comparison. And now that I have confidence from production that everything works as I expect, I can remove this original one, and really I should have done it. So git status too excited, I can't type when I'm excited. Tested successfully in production. Maybe a slightly better error message than that, commit message than that. So now we can start to go through. We don't need this anymore. And on next doesn't take a deteamed result, it takes a chain result. I don't actually think it can take undefined anymore. I think it always gets a chain result out of this, and the type system isn't complaining, so I think that's true. We didn't learn our mistake from above, so we do need this case where we send s.error or unexpected error, please log a bug. Now I think I have to put that because we could say else if s.error, then okay, so now we're fine, and now logically we know that's the only possible result, but we can send, you know, we could have a catch-all. Just because logically we can't have an error doesn't mean we won't ever have an error. Let's give the human some information. We can get rid of that. We can get rid of that. Let's start looking what we've got in here. I don't think we use anything in this file anymore. I bet maybe we test it. Deteamsify. Yeah, okay. So let's double check this. we copied this test case, or part of it. So let's have a look. What did we copy? We copied those. We can duplicate them. So I've got this link here, and that gives me this output. If I got all the way to the end, I couldn't see. Now, in the interests of time, I won't copy all those test cases over. Assertion error expected hidden URL to download URL. Okay, sorry, my bad. So we'll assume I've gone through and copied those across, so we can delete that spec file and view URL. Let's assume I've copied this across, we can delete that spec file. Now the comment I'd make here is, we've said we're not going to test the individual links in the chain because we don't care about the implementation. Now, arguably, if we find these readers, arguably we do care about these readers. These two are really the meat of the application for us, and we might really care. But we can test the chain link, or we can extract this code and test the extracted code. Right now, I'm not going to, but you could approach the application that way. I'm confident we're not. See, we can slowly walk up here. The IDE is saying you don't use that. No. And rather than let it search all the text in the application, we don't use it. And now we don't use that, and now we don't use that. So we can delete this file. Messages.ts, I'm not sure how much value that adds, but we'll leave it there for now. URL, we don't use this exported method, which means we don't use this one or this one, and now that file's empty as well, so we can get rid of that. And now we just have our index that coordinates things. We have our chain of responsibility. We have my fancy web framework for writing HTML into the page without bringing in a dependency, and we have our messages. You could turn chain of responsibility into a folder, have each of these links in a separate file, or separate it out some way. It's quite a big file, 124 lines, but you know, that's we're into refactoring the application, not this move from one implementation to another. Let's double check the tests still pass. They do. Check it still builds. And we'll just come back here and test that. Works as expected. And so git status and commit, and we can say implements new deteamsifying code in production. Now you might, in your world, this might be a pull request, you might squash those commits before you push them. You can handle a lot of these things differently than the stylistic choices I've made and the approaches I've taken. But hopefully that shows you how you can use chain of responsibility in an application, how you can safely implement a new change against production by slowly switching one thing over for the other from building it alongside, and hopefully it was interesting. Thanks so much for listening to what's turned into a very long video.